Find a polynomial p of x of degree 3 that has integer coefficients and zeros 1/2 and 3 minus I. So because we have this complex zero of 3 minus I, but we want integer coefficients, we don't want any complex coefficients. So we are going to use the conjugate zeros theorem, which tells me that if 3 minus I is a 0, then its conjugate is as well. Okay, so using our notation, we've got this number, this complex number z, which is 3 minus I. And its complex conjugate, z bar, is the same thing, but we just change the sign in front of the imaginary part. So 3 plus I. And this is going to be another 0 of the polynomial. So now we can go ahead and create a factored form of our polynomial. We have x minus 1/2, and then we have x minus 3 minus I, and x minus 3 plus I. And this is a factored form of a polynomial that has those zeros. However, it does have this 1/2 in there, and I don't really like that because I want integer coefficients. So just to be safe, I'm just going to multiply this by a 2. And if I bring that 2 inside this first set of parentheses, I get 2x minus 1. And now I'm working just with integers, and that makes me happy. And then for each of these, I'm going to go ahead and distribute the minus. So I've got x minus 3 plus I and x minus 3 minus I. Now, I'd like to go ahead and multiply all this out just to make sure that my complex numbers really do cancel out if I multiply all of this out. So we are going to start by actually taking these two factors that came with the complex numbers, and we're going to go ahead and multiply that out. So there's a lot to do here, a lot of distribution. So we're going to color code it to be safe. So I've got, first of all, my x times x, that's x squared. And then I've got x times negative 3, that's negative 3x. And then I've got, let's see, x times negative I, that's negative ix. Okay, and then I've got this next, I've got negative 3 times x, negative 3x. And then I've got a negative 3 times a negative 3, and that's positive 9. And then I've got negative 3 times a negative I, and that is plus 3i. And I am running out of colors. Let's see, I times x, so plus ix. And then let's see, let's do the next one is I times a negative 3. That's a negative 3i. I know my colors are kind of blending in. They don't look super distinct anymore. Let's do one more. And just for that last set, which is I times a negative I, that's minus I squared. Okay, that was a lot of stuff for just multiplying these two things together. But you'll notice that there's actually quite a bit that cancels. Okay, I've got here a negative ix plus ix. Okay, so those are gone. And I've got a plus 3i and a minus 3i. And those are gone. Okay, and then I can combine the minus 3x minus 3x. Okay, so I've got this x squared out in front. I've got combined those two, and I have minus 6x. And then I've got this plus 9 and this minus I squared. And minus I squared, remember, is positive 1, because I squared is negative 1. So this is a positive 1, and I have plus 9 plus 1. That gives me plus 10. So after all is said and done, multiplying these two things out, we actually get a very nice quadratic. Okay. And then I've got my 2x minus 1 out in front. And you'll notice all of my i's are gone now. So I do know that I'm going to have my integer coefficients. I'm going to go ahead and just do my last step of multiplying these two things out. so we can see it in expanded form. So let's get crazy with colors again, huh? So 2x times x squared is 2x cubed. And 2x times negative 6x is negative 12x squared. And then 2x times 10 is 20x. And then we've got our negative 1 times x squared is negative x squared. And negative 1 times negative 6x is positive 6x. And then negative 1 times 10 is negative 10. So now we can go ahead and combine some like terms. I've got this x squared here and x squared there. So my 2x cubed out front, combining those two, I get minus 13x squared. And then I've got this x term and this x term. 20x plus 6x is plus 26x. And then finally I've got my minus 10 at the end. So there's my polynomial p of x that has integer coefficients and the given zeros.